A body moves such that its displacement from an origin O at time t seconds is x meters, where x is equal to 4 sine 2t. Prove the motion is SHM. So x is 4 sine 2t. So the velocity, or dx dt, or sometimes written x dot, like this, is going to be 4 cos 2t, but don't forget to use the chain rule, multiplied by the differential of the inside, which gives us 8 cos 2t, and then the acceleration, which we often write as x double dot, is going to be negative 8 sine 2t, again multiplied by the differential of the inside, giving us negative 16 sine 2t. So, if we compare this with this, we can see that the acceleration is equal to negative 4x. And that's the very definition of SHM. If we have x double dot is negative n squared x. We want to determine the period and amplitude of the motion. So we can see from here, remember this is n squared, that n equals 2. T is equal to 2 pi over n. So that's 2 pi over 2, which is, and here we know it's seconds, so that's going to be pi seconds for the period. Now the amplitude we just get from here. Remember that this part, the sine, will go backwards and forwards between negative 1 and 1. We know the shape of the sine graph. Therefore, x will go backwards and forwards between negative 4 and 4, which means that the amplitude is going to be 4 meters. How far does the body move in the first second? Well, let's think about that. So if these are the extreme points, and this is the mean position, when t is 0, sine of 0 is 0, so x is 0, so our body is going to start here. And if we look at the expression for v, that's going to be initially positive, so it's going to go this way to start with, until it gets out to here. Then it will come all the way back over to here, and then back to the middle position. And all of that takes pi seconds. So it's going to be back at the middle halfway through that motion, pi by 2. So that means this is pi by 4, and this would be at 3 pi by 4. Now pi, of course, is 3.14 and something, so pi divided by 4 is less than 1. So it's actually going to do this and come back a bit. So we know the amplitude is 4, so this is 4 meters out to here. So if we now work out x of 1, that will tell us where it is on the line on the way back. Remember, pi by 2 is 1.5 something, so it's certainly not getting back as far as O. So we want x of 1. So we need to be in radian mode, which we are. Let's go for decimal. And x of 1 then is going to be 4 multiplied by sine 2. So that's 3.64, we'll call that. So this is 3.64. So how far does it come back? 4 take away 3.64. So this is 0.36. So this was 3.64 to 2 decimal places, and then the distance is going to be the 4 add the 0.36, so 4.36 meters. Now, could we have done that with an integral? Well, we know that this is the velocity just here, so if we integrate the velocity, which is 8 cos of, I'm going to use x rather than t, and we want the first second, so that's from 0 up to 1, and then to avoid the situation of some of it coming backwards, it's just like working out an area. We'll just take the modulus and calculate, and there we go, 4.36.